Okay, this video is so that you can draw a concentration time graph using a RIChE Conc table. Your textbook calls them ICE tables. Sometimes you might see RICE tables. I'm going the whole way just to remind you of all the parts. So I'm calling it a RIChE Conc table. Okay, so we're doing this example with the classic Haber process to make ammonia. So we've got one nitrogen, 3 hydrogens making 2 ammonia molecules. So with these, to draw a concentration time graph, you need some information about your initial reactants or products. So you've got 1 mole of nitrogen and 3 moles of hydrogen, and they're being added to a 1 litre vessel. That's a concentration time graph, so we need moles and volume. And they reacted, so there's no mention of ammonia to start with, so there's no product to begin with. Then after they've reacted, when it reaches equilibrium, you get 0.6 moles of ammonia. So from this information you should be able to draw a concentration time graph. So you set up your RIChE Conc table, work out which direction the reaction is going until equilibrium is reached. So because there's no products, straight away you realise that there's only mainly forward reaction. So how many, to work out your concentration of each of these at equilibrium, you're going to have to work out how many moles of nitrogen and hydrogen actually reacted in order for you to produce this 0.6 moles of ammonia. Then after they reacted, how many moles of nitrogen and hydrogen actually left, and find the concentration of all the reactants and products to plot the graph. So the last thing is finding the concentration. This particular example is fairly easy. Alright, so your RIChE, RIChE Conc table, the R stands for ratio, then your initial mole, what you started with, then you do your working out in this change area. Then you need to know the moles of each at equilibrium in order to work out the concentration of equilibrium for each of them. Alright, so it's a 1 to 3 to 2 ratio. We started for this particular example because it's easy. We only start with 1 mole and 3 moles, so exactly stoichiometric amounts to make it easier. And there's no product to begin with, and we know that at equilibrium we ended up producing 0.6 moles of ammonia. So you can see from the right at the beginning, you had no ammonia, you produced 0.6, so then you must have had the reaction going in the forward direction, so you've added this. So sometimes these will be more complicated. You might be removing this to get to equilibrium when you look at so you might get an initial amount to start with. Alright, so our reaction is going in this direction to produce this. So we want to know how much nitrogen was used to produce this, how much hydrogen was used to produce this. So you need to, when you're going from the amount of one chemical stoichiometrically to another chemical in a reaction, you need to use your mole ratios. So you want to know how much nitrogen was used to produce the ammonia. So it's a 1 to 2 ratio. So the amount of nitrogen that you would need is half the amount of ammonia that you produced. It's good sometimes to write just beside, because we've got the number of moles of nitrogen initially, we've got the number of moles of nitrogen that's reacted, and we're going to work out the number of moles of nitrogen at equilibrium. So sometimes it's good just to label things, initially reacted and equilibrium, to keep it clear what you're doing. Alright, so we started with 1 moles. We've used 0.3 moles to make this 0.6, so therefore at equilibrium we'll be left with 0.7 moles. So if we do the same thing for our hydrogen, it's a 3 to 2 ratio. So to produce 0.6 moles of this, you would have to use 0.9 moles of hydrogen. You started with 3, you've used 0.9. So you'll be left with 2.1 at equilibrium. So this is the unreacted, or the number of moles at equilibrium. So you could write number of moles at equilibrium here. Okay, so you don't need to use a RIChE Conc table. You can write it out, the steps. So to make this example easy, to draw the graph is a concentration time graph, so the moles must be in as concentration. So concentration is the number of moles in a volume. So to make it easier, we've made our volume 1 litre so that the concentration is exactly the same number. Alright, so we have, and we could turn to plot the graph. This would have to be concentration, so you start with 1 mole per litre and 3 moles per litre of hydrogen, and you end up with 0.7 and 2.1. So this is the graph that's drawn. So we'll go through how did they know how to draw it. So you need the concentration of your reactants initially, so you've got 1 mole per litre, 3 moles per litre, and no product. And then the hydrogen, you've used 0.9 mole, so you've gone from we can say that this is 3 moles. For this example, we'll say this is 3 moles. It's 3 moles per litre, and you've used 0.9 moles, and it's 0.9 moles in a litre. So we can just use these numbers as moles just for this example. So you've used 0.9 moles, so it's gone down to 2.1 moles, which is 2.1 moles per litre. So you need to, if we're drawing the line, need to work out when equilibrium is reached and bring that line in an even curve down to here, and then from that point on it'll be flat at equilibrium. Okay, so we do the same with our nitrogen. We used 0.3 moles, started off with 1 moles, we've gone down to 0.7, so you just do a curve down to this equilibrium point and then straight line. And we started with no ammonia, we've produced 0.6, so you do a nice smooth curve up to here. Alright, so I've done this with actual numbers because they did that last year with actual numbers. A lot of the times they're just getting you to do it freehand, so they'll show, you know, this has gone up to here, so or one of them has gone, you know, moved, so how do we move the others? So a lot of the times you'll just do it with ratio. So this is a 1 to 3 to 2 ratio. So the 1 obviously is the one that you're going to base everything on. So this is, the drop is a mole ratio amount. So if this drops the equivalent of 1, then the length of that line, you would increase that 2. So you're making that go up 2. And you would drop this 3 of that line. So you can just do these lines once you know one of them. You know, we knew the 2, that this had gone up to 0.6. So we could have just done these lines with ratios. So this has gone up for 2 moles. So if we drop that half the amount and drop that 3 times the amount, so you could just have drawn it freehand. Okay.